Welcome everybody back to Chem 330 week 4 discussion. Alright, and to start off this session I'm going to teach you two general ideas, and these are one of them is this is something that's very important across the remainder of the concepts we would learn. But for now we are going to restrict those concepts just to alkenes, okay? And that is cis and trans isomers, okay? Remember how when we learned say C8H18 and I have you write at least 4 to 5 isomers, right? Now if you look at it, this is a CnH2n plus 2, right? So it's an alkane, right? Now and then we learned if it's C8H16 then it's a CnH2n, so it must be an alkene, right? And I only had you write 3 or 4 isomers for the homework, but let's say and then we may have, say, let's take this compound right here. So okay, CH3, CH2, CH double bond, CH, CH2, CH2, CH3. Okay, this is 1, 2, 3, 4, 5, 6, 7, right? So it's actually 3 heptene, right? Right. Now something I have not taught you is this compound, okay, contains a double bond, right? Right, now this is not for, this must have been C7H14, okay? Okay. Now if you notice the double bonds right there, and then on the carbon that's containing the double bond, the 2 carbons are this, right? Now that carbon is attached to, I'm going to use different colors here so you can see, it's attached to, each carbon is attached to a hydrogen, right? It's attached to a hydrogen, but it's also attached to this group, right? That's what it really means, right? And this carbon is also attached to a hydrogen, and it's also attached to this group, right? And this is an ethyl, and this is a propyl, right? Right? Very good. Now something we didn't go in earlier is I had you stop here, 3-heptene. Very good. Now but if you write it, this carbon is attached to a hydrogen and it's attached to, it really doesn't matter which order you write, just write it in one order or the other, right? And I'm going to write exactly the same way for the other one. Okay, it really doesn't matter how you write it because that's the whole purpose of it. Okay, now we have to determine, are all these groups cis to each other or trans to each other? Okay, cis means are on the same side, trans means are on the opposite side, right? So cis is same side. What is on the same side? That's what we're going to look at. Trans means opposite side. Okay, opposite side, right? Now we got to assign these 4 groups that are attached to this carbon and carbon double bond with various letters. Typically A, B, C, D would work, right? Now if you look on this carbon, this is a smaller group, it's only hydrogen, right? It's only 1. This is a bulkier group, right? A bigger group, right? So that means this gets letter A or 1, this gets letter B. Okay, you usually assign A to a group that's bulky, B to a group that's smaller. Similarly on this side, this is a bulkier group, this is, okay, a smaller group, so it gets B. Now if you notice, the A and the A are on the same side, right? We look diagonally across, right? Only if B and B are diagonally across and A are diagonally across, we call that compound a trans, right? But in this case, A and B are opposite, that means A and A are next to each other, right? So that means this is a cis, right? Right. Now let's go write the alternate version. Now you can just flip one side and it will automatically become a trans. You don't need to flip both sides. You just have to flip the groups, push one to the top, the other one to the bottom, right? Now it doesn't matter again which side you're going to make that happen, right? So this would be, I'm just going to move this up and move the other one down. You don't need to flip both, then you'll end up with cis again, right? You can only flip one or the two. So let me get a blue actually better. So again, this is a smaller of the two, so this is A, this is bigger of the two, this is B, smaller of the two, A is larger of the two, right? Let me actually erase it so you can see it later, what I have here. Okay. So this is B, smaller of the two. Again, this is extremely arbitrary. You know, this A and B, you could call it 1, 2, 3, 4, you can call it element OP. It doesn't really matter what you're going to call it. So this is B, okay? Just be consistent, and A goes for the larger group, and this is B for the smaller group, A for the larger group. Now if you see, A and A are diagonally opposite, B and B are diagonally opposite. So this is a trans, right? Typically speaking, okay, trans compounds are more stable than cis, because in chemistry the further the groups are apart, that's a good thing. So trans compounds are foundationally more stable, okay, foundationally more stable, okay, than cis. Okay, so if we were to go back and redraw this compound, okay, so again, when I ask you to write isomers, you don't have to say cis or trans. I would only have you predict if it's cis or trans given a specific situation. So if I give you this compound and have you determine the same compound that we had earlier, and then I have you determine if it is a cis or trans, and also name it, which means I would specifically give it in this format, okay? I will not give it in any other format. When I have you write isomers, that's a different story. But when I have you write the name for a specific compound that I've given you, then you would name it the following way. Okay, as I said, just to be consistent, I'm going to draw this way. This is what I had, right? Now I said, you go get my blue, right? This is the bigger of these two groups. You just look at it on either side of the double bond. That's what we're doing. Okay, on this side, this is bigger, so that gets A. This side, this is smaller, so it gets B. On this side, this is bigger group, because a lot of carbons and hydrogen. This is small B. Same for here. This is B, this is A, this is A, this is B. Right? You still have to follow the long chain to get the longest chain, and we know that it was 1, 2, 3. You start from the side that contains less carbons on either side of the double bond. This contains less carbons, so 1, 2, 3, 4, 5, 6, 7. We said it's 3-heptene, right? Or heptrihine, but I'm just teaching you this way. They're both the same compounds. That's not going to change. So it's 3-heptene for both of them. But here, A and B are opposite, A and B are opposite. That means A and A are right next to each other. So this is a cis 3-heptene. This is A and A are opposite, B and B are opposite. So it's a trans 3-heptene. Now how difficult was that? Let's say something I have not taught you yet, okay? But say I give you, okay, compounds like this. Let me go get a different color. Something we have not got to naming with chlorines and bromines. Okay, so let's say I give you this compound CHCl double bond CH. Okay, Cl. Okay, and then the same for the opposite is true. You just flip one of the sides. Okay, I'm gonna keep this side always consistently there and flip this one. Okay, again, there's only two kinds of substituents. They are just around in here. Chlorine is a bigger molecule. If you go to the periodic table, you see chlorine is a bigger molecule. So Cl, it's not carbon L, it's Cl. So this is A, this is B, this is A, this is B. Only A and B are opposite, but A and A are right next to, adjacent to each other. So this is cis. Again, we will learn the naming of it in a separate section. But for now, A, this is B, this is A, this is A, this is B. A and A are opposite, B and B are opposite, so it's trans. Okay, now we only use cis and trans isomers, okay, when you have only two substituents of the chain. Okay, you see there's only two substituents, hydrogen and chlorine, and they're the same on either side, just where they are what different, right? So we use cis and trans, right? Now we will use different letters when they are different. Okay, so let's go do that. So let's say instead of what we've been doing is we have two identical groups on either side of the carbon containing the double bonds. It's just they are either adjacent or opposite to each other. But this time, if you have something like this, keep in mind some of you are still writing CH3 to this bond. CH3 cannot attach to a bond, it has to be CH2. Okay, let's say this is the compound. Okay, first let's review our knowledge of naming it, because that is important. Okay, whether you write cis or trans or what I'm going to say now, you still have to get the naming right. Now if you're still struggling, this is the way we write it. But to actually make it easy on yourself, just go ahead and write it in a straight chain format, so you will never have to find it so difficult to name it. Okay, all I have done here is this. Okay, now go get the longest chain. Let me get a different color. This is again kind of a review of what we've learned. This is really my longest chain right here, straight chain right here. So it's 1, 2, 3, 4, 5, 6, 7, right? Now which side do we start numbering? I know some of you are still confused on that concept. Okay, so let me go ahead, and this is my longest chain, right? Some of you are still confused on which side to number. Well, your longest chain should contain the double bond, but if you look at it visually, this side is more crowded because of the CH3, so you should start numbering from this side. So 1, 2, 3, 4, 5, 6, 7. Okay, so that means it's 3 methyl, right? This is 3 methyl, right? 3 methyl, and it's between 3 and 4, and it's a 7, so it's 3 heptene, right? That's the actual name of the compound. You've got to get that first. Now if you are still not sure about naming from our previous 3 weeks of material, I highly recommend you watch those videos and also get my help. But now we got our name down. Now it's a question of, we're going to use a different naming instead of cis and trans. Cis and trans can only be used when the type of groups you have on both sides are exactly the same. If you don't have identical groups on both sides, then you use Z and E. Okay, Z for Zusammen and E for Integen. I think it's German for same side and opposite side. Okay, let's not go into the German pronunciation or the actual word letters for the word. Let's just know it as Z and E. Z is very similar to cis, and E is similar to trans. Okay, but you cannot use cis and trans because none of the 4 groups, the groups on either side are not identical. So we have to use Z and E, and Z is similar to cis, E is similar to trans. Okay, so again the same thing applies. This is the bigger of the two, so it gets A. This is smaller of the two, it gets B. This is smaller of the two, so that gets B. This is bigger of the two. A and B are opposite. That's not trans, so that means A and A are adjacent, right? So this means this is a Z. You write the name 3-methyl 3-heptene. Now let's look at the other way around. Let's go get our black. C double bond C. As I said, I will only flip one side. If I flip both sides, then I'm going to have the same compound again, right? Logically, you should have no difference. So I just flipped this group to the bottom and the hydrogen to the top, right? So now let me go get my blue. So this is B, this is A, this is B, this is A. If you notice, A and A are opposite, so that means it's the same 3-methyl 3-heptene. Now again, getting the name right is very, very important. And then because like groups are on the opposite side, it's a E 3-methyl 3-heptene. So you should really know when to use cis, when to use trans. Alright, now let me give you something else that's a little tricky, something we have not gotten used to. So let me put something else on the screen here. Okay. What you see on the screen is the priority of groups. Okay, that means Br has the highest priority and hydrogen has the least priority. You don't have to remember this, or probably will be attach it to as an appendix to your test, so you don't have to memorize it. Okay, there's no real point in this particular sequence. Okay, so let's say now I come back and I say I give you this C double bond C HCl NH2 and Br. Okay, let's say I give you this compound and I first want you to name it. Maybe in the next slide let's worry about the naming, but because I want to do a bunch of examples involving Cl and Br as just for the naming. Okay, let's figure out whether should we use cis and trans, okay, or Z and E. Which of them should we use? What do you think? Well, clearly the two groups on one side are not same as the group on the other side, so we are going to use Z and E in this situation. But again, Z is same as cis, E is same as trans, right? So that means you come to this side, don't get them all clubbed up and start putting 1, 2, 3, 4 or A, B, C, D. Okay, you still have to look at it case by case basis on either side of the double bond. On this side, Br clearly has a higher priority over nitrogen. Okay, we only focus really on the element that's directly attached to the carbon. So on this side, okay, the NH2 gets the lower ranked substituent B, and then Br is higher in priority, so it's A. And again, chlorine is here, hydrogen's here, so chlorine gets A and B, right? Clearly A and B are opposite, but A and A are adjacent, B and B are adjacent, so it's a Z, right? So let's go get and draw. You guessed it. What I'm going to do next is just flip one of the groups. So it's C double bond CHCl and Br. You don't want to flip both. You only flip once. Again, there may be questions where you will be asked to do this and I will give you the name. Okay, so that means again still let's get our blue. And Br is direct. You only focus on the element that's directly attached to the carbon, and Br it is, and Br is higher in priority over nitrogen, and chlorine is higher priority over hydrogen. A and A are on the opposite side, so that means it's a E. Okay, good. So let me give you a list of things that we will continuously come back and use in terms of naming. We've so far in the first 3 weeks, or up until you saw this video, you have not seen elements other than carbon and hydrogen, not even oxygen, because we were purely discussing about alkenes, alkynes and alkynes with no derivatives of it that involves different elements. right? So let's go. Actually, I'm going to stop here, and in the next video I will probably teach you about the naming of some of these compounds. Okay, but so you should know the summary of this video is you should know how to write, how to figure out when it's cis, when it's trans, or when it's Z, when it's E. Okay, you cannot use cis trans when it's supposed to be ZE, or you cannot use ZE when it's supposed to be cis trans. Okay, so I will give you some practice problems in class, but the point of this particular video is to help you understand, because the cis trans and Z and E is not a concept that you just learn once and forget it. You will be asked to write and name it either in this class or any pre-professional exams that you might take. You will see these type of questions on that test. Alright, so when I come back in my next video, I'm going to talk to you about naming some of these compounds. Alright, stay tuned.